This is my talk, Computer Heal Thyself, Automating On-Call, so you can sleep through it. My name is Alethea Power. I've worked in auto-remediation, which is what I'm going to cover, and I'll explain that term in a minute. I've worked in auto-remediation for about 10 years. I built one of the world's first and largest auto-remediation services, and now I'm building an auto-remediation service in conjunction with Kim and the ZNOC team here at Zendesk. So, what is the purpose of auto-remediation? Well, tech companies have been finding through the DevOps revolution, not revelation, I mean, I guess it's kind of a revelation, over the past number of years that they can get better product quality, faster product development velocity, and higher service reliability if they give product engineering teams both the authority, the responsibility and the authority to manage the full life cycle of the software that they're writing. So that means not just writing code, but the engineers who write the code also push the code out to production. They operate the code in production, and they respond when there are outages in production. So this causes a virtuous, tight loop. The engineers who are writing the code are best equipped to solve problems when they occur. And when those problems occur, it gives those engineers a lot of extremely useful information about how to change that code or repair it. So quality goes up, speed goes up, et cetera, et cetera. But this introduces a whole new set of responsibilities for software engineers that they have not traditionally had to take care of, which means we have to provide them with tools to make these jobs easier so that they can focus on the part they understand and not have to worry about lots of things that distract them from the focus of the code. So, auto-remediation is meant to be a tool to help address with the remediation of outages. And I'm not talking about the Fukushimas of the world. I'm talking about much more frequent outages, the kind that happen 20 times a day, the kind that happen at 4 a.m. and at 4:45 and at 6 and at 5:30 a.m. So, what does this look like in practice? Traditionally, you have a monitoring system that detects when you have outages in your infrastructure with your services. That monitoring system gives alerts to engineers. Now, this could be in the form of engineers sitting in front of a dashboard of alerts, 24/7 watching it. It can be in the form of alerts paging engineers in the middle of the night and waking them up, et cetera, et cetera. And then engineers take their own knowledge and documentation recorded in what's frequently called runbooks to execute various commands in the production environment to try and solve these problems. So these commands can be things like, if you have an application that's wedged, maybe you restart it. If you have a hard drive that's full, maybe it's full because there's a bunch of errors spewing into a log, then maybe you truncate that log. If you're in the middle of being attacked, if you're in the middle of a DOS attack, maybe you change some routing rules to black hole incoming requests. So these are the kinds of things I'm talking about. So an auto-remediation service replaces these two components. The engineer gets replaced with the service, and the runbooks get replaced with remediation code. So instead of having human-readable documentation about what to do, you have blocks of code. And the auto-remediation service goes and executes this code in response to alerts in the monitoring system. And then engineers can sleep through the night. Their talents are better used for instance, instead of waking up to restart a service that has a memory leak, they can be well rested in the morning and figure out why it has a memory leak and fix that. And in general, we can take better advantage of the knowledge that we have across all of our engineers, the engineers that are being woken up and the engineers that are watching these dashboards. We've got a lot of really knowledgeable, talented, intelligent people, and we want them to be able to use their skills in the most sophisticated and interesting ways possible. So we're trying to automate as much as we can. So I'm going to look at an example here. This is a configuration file for the auto-remediation service that we're building. I tried to design the configuration language to be as simple as possible while also being flexible enough for what we're trying to accomplish. So let's walk through it. This file says, if you have this issue on these hosts, then it should run this job in response, but don't run it more often than that. So specifically, if the OS query agent is busted on web servers in US West 1, then you want to run this block of remediation code, but don't do it more than 5 times per hour per cluster. Make sense? So let's go look at this thing right here so we can understand how that looks. So we're also building an SDK, mostly built by engineers on Kim's team. And this SDK includes a lot of convenience objects and convenience methods so that the people writing remediations can focus just on the logic that they care about. And they don't have to worry about things like SSH authentication and properly rotating keys and how do they get authentication into AWS so they can reboot EC2 hosts and stuff like that. We abstract all that away for them, and we do it in ways that are that make our security compliance team happy. Every remediation uses a different SSH key magically. So this remediation, you can see in 4 lines of code, it could fix this problem. So let's walk through these lines. First, you import our SDK, so you get all these convenience objects and methods. Then you subclass our remediation class and override the run method. And then inside of that, you get this convenience object. If it's an alert on a host, you get self.host. The remediation doesn't even have to know what host it's working on. It can if it wants. Self.host.name will tell you a host name, but you don't have to. And you get this method, self.host.run, which magically does lots of SSH things in the background and can run this command to go restart that service. So it's that straightforward. We're trying to make it as simple as possible for our engineers. It's pretty complicated on the backside. Here's a pretty simplified picture of what the backside looks like. So Swati, you did a magic thing with a dot. I don't know how to do it, so I'm just going to go point. So that thing, the alert mapper, pulls in alerts from PagerDuty. That's who we use for monitoring, or where we consolidate our alerts. And it runs those alerts through the configuration, like the configuration files we were just seeing, and calculates what remediation jobs to run, inserts those jobs into the database, and then that thing, the job launcher, pulls the jobs from the database, hands them as config files to Kubernetes, and Kubernetes executes them inside of containers. We're running them in containers because I've built this before, and engineers make jobs that take 100 gigs of RAM and all the CPU you can use. So we don't want any job to choke out the others. And lastly, since we have this nice infrastructure in place already with a beautiful SDK, we're giving people the ability to launch proactive jobs using a CLI to do things like kernel upgrades and other stuff that's not necessarily responding to alerts. All right, thank you.